Okay, so we are on 6.3 in the similarity unit. So now we're going to talk about similar polygons. Similar polygons are two polygons such that their corresponding angles are congruent. So corresponding angles are congruent, and their corresponding sides are proportional. Okay, so these are not congruent figures, these are similar figures. List all the paired congruent angles for the figures, then write the ratio of the corresponding sides as a statement of proportionality. So they tell you in this statement what matches up. So angle A, first letter, matches up with angle D. So A is congruent to angle D. Angles are always congruent on similar figures and congruent figures. Angle B would be congruent to angle F. And angle C would be congruent to angle E. And again, I just went off the similarity statement. That means that side length AB, so A to B over D to F, is in proportion to B to C over F to E. Again, I'm using my letters. B to C, second, third, F to E, second, third letter, which would then be proportional to A to C, first and last, with D to E. So this is my statement of proportionality. Here are my corresponding angles. Okay? Go ahead and pause me, do number 2, unpause me when you're done. So angle W congruent to angle M, angle X congruent to angle N, angle Y congruent to angle O, and angle Z congruent to angle P. Then we have WX over MN is equal to XY over NO, which is equal to YZ over OP, which is equal to WZ over MP. Again, I got all those just from going this figure to this figure. Now, if you set this up, and maybe this one was over here, that's fine. The order of that doesn't matter. Or if you flipped Y or ZY, then just do PO, and that would be fine also. Okay, scale factor. Scale factor is the ratio of the length of the two corresponding sides of two similar figures. So determine whether the polygons are similar. If they are, write a similar statement and then find the scale factor. If they are similar, all angles would be congruent, which all angles are congruent here. And then the side lengths would be in proportion. So like 20 over 25, this side with this side, would equal the ratio of 16 over 20, this side over this side, which would equal the ratio of 12 over 15, which would equal the ratio of 24 over 30. Now, I knew what matched up to one another because this is 1 arc, 3 arc, so it has to match up with the side between the 1 arc, 3 arc. 1 arc 90, 1 arc 90, so those two have to match up. And then what I would do is I would either reduce these fractions down, and if I reduce them down, then they have to be reduced down to the same fraction. Or I can go through and turn them into decimals. So this is 0.8. So I did 20 divided by 25. 16 divided by 20, 0.8. 12 divided by 15, that's 0.8, or 8/10, right? And then the last one is 8/10 also. Since all those are congruent, and since all angles are congruent, then these are similar figures. So I would say figure FJHG is similar, now match it up correctly, ZWXY. And the scale factor is one of these fractions, but reduce it. So let's just look at 20 over 25, because all these are going to reduce down to the same fraction. The scale factor is 20 over 25 reduced. So 5 goes into both. 5 goes into 24 times, 5 goes into 25 5 times. All right, next one. Angles are congruent, so that's good. Now I'm going to do 16 over 4, should equal 24 over 6, which should equal 16 over 4, which should equal 24 over 6. 16 divided by 4 is 4. 24 divided by 4 is 4 also. 16 divided by 4 is 4. 24 divided by 4 is 4 also. So those are all congruent. So scale factor is 4. Now, that is the scale factor going from the small guy to the big guy. You would multiply the small guy by 4 to get to the big guy. If I wanted to go backwards and go big to small, it's the reciprocal of that. So if you think of 4 as a fraction, that would be 4 over 1, so the scale factor going backwards would be 1 over 4. Right? Same thing here. Scale factor of big to small is 4 over 5, because we're getting small. But if I want to go this way, the scale factor would be the flip of that, so 5 over 4. Okay? All right, next page. Perimeters of similar figures. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. Okay, so find the scale factor of this guy going to this guy. So we need to see what matches up. W matches up with M. N matches up with X. So we need to find a side that matches up. So it looks like 8 matches up with 10. So 8 matches up with 10. They want me to go from this guy to this guy. So we are getting bigger. So we would want a number bigger than 1 because we're getting bigger. And when you multiply by a number bigger than 1, we get bigger. So it would be 10 over 8. But we need to reduce that. 10 over 8 reduces to 5 over 4. So the scale factor would be 5 over 4. Okay? Find the values of x, y, and z. So I'm going to use this 10 over 8 to find x. So 10 over 8 is equal to x over 12. X and 12 match up. 10 and 8 match up. Since I use 10 on top, I have to use x on top. We're going to cross multiply, and I get 8x equals 120. Divide by 8, divide by 8. So 120 divided by 8 is 15. So x equals 15. All right, next, let's find y. Y is this side length. That side length, if you notice, this is 10 and this is 10, which means that this side length and this side length would have to be equal also. So they're going to be the same, so y would just be 8. And I know that because these are similar figures and they have to stay in proportion. And then we have z. Z is that obtuse angle. So z matches up with this angle over here. So z is equal to 135 degrees. Find the perimeter of w to x to y to z. Well, that would just be the 12 plus the 8 plus the 12 plus the 8. So essentially that's 20 plus 20, which is 40 units. This guy, so perimeter holds the same scale factor as side length. So remember before we said 8 over 10, those two sides match up, right? 8 and 10. Okay. 40, we know that this has a perimeter of 40, and that is on the figure across with the 8. So 40 would go across from the 8. We want to find the perimeter of this figure, right? Which is the figure that has the 10. So we're going to set it up like a proportion, cross multiply. We get 8x equals 400. So x equals 50. Right? Let me just make sure. Yep, 50. Which makes sense because this guy is bigger than this guy. So this guy's perimeter should be bigger. We also know that this is 10, this is 10. We found earlier that x was 15. So 15 and 15 make 30. 30 plus 10 is 40. 40 plus 10 is 50. Find the ratio of the perimeter for a perimeter from one to the next. Perimeter of this guy is 50. Perimeter of the other guy is 40. If I reduce that down, that is 5 over 4. If you notice, the ratio of those perimeters is equal to the side length ratio. So the scale factor is the same going from sides to perimeter. Okay. Next page. The two triangles are similar. Find the values of each variable. Go ahead and pause me and try both of these on your own. See if you can set up a proportion that you can solve. So on this one, they are similar. So we already know that they're similar. I know that this guy matches up with this guy. I know that this guy matches up with this guy. And I know that this guy matches up with this guy. I have to solve for m and n. So we're just going to start with m. So I'm going to write m over, so m over what it matches up with, 5.5, is equal to, now I need to set it to equal to a ratio that has a number on top and bottom. So that would not be my n with my 8, but that would be my 6 with my 12. Now I started with m, so I need to use the number that's on the triangle with the m. So that would be the 12, and then I put 6 over here. Okay? I'm going to cross multiply, and I get 6m equals 66. Divide by 6, and I get m equals 11. Now to find n, I'm going to stop right there real quick. There are numerous ways that you can set this proportion up, and your way is just fine, as long as you can always check yourself. Diagonally, you should have the same numbers across from one another that I do. So your 6 should be diagonal from your m. Your 5.5 should be diagonal from your 12. And if that is true, then you've set it up a correct way. To solve for n matches up with 8. So I'm going to do n over 8 equals. Now again, I have to come up with sides that are already given to me with numbers. I could use this 11 and 5.5 because now I both have numbers there. But what happens if I had gotten m incorrect and I used it in this problem? Then I'm for sure going to get n incorrect. So that's why I go back to the numbers that they gave you, so that you're not using an incorrect answer to possibly get it wrong. So n matches up as on the same one as the 6. 8 is on the same one as the 12. Cross multiply, I get 12n equals 48. Divide by 12, and n equals 4. Same process over here. Now, though, 15 actually matches up with 10, because if we have a one angle, and this guy matches up with this guy. So I'm going to do 15 over, this time I'm going to do m plus 4 equals 10 over m. So this over this equals this over this. 15 and 10 should be across from one another because they are representing the same spot on either triangle. Again, you could set this up multiple different ways, but your diagonal things should be the same as mine. I get 15m equals 10 times m is 10m, plus 10 times 4 is 40. I'm going to subtract 10 from both sides, and I get 5m equals 40. Divide by 5, and I get m equals 8. Okay, next one. Go ahead and try all parts of this, and pause me, unpause me when you're done. Okay, so this is what your picture should look like, the pool inside the fence, right? The scale factor of the pool to the fence. So if I'm going from the pool to the fence, I'm getting bigger. So that would be the 50 over the 30. You could think of it as the 30 over the 50 if you want, and reduce that down to 3 over 5. But if we're getting bigger, it has to be the flip of that because we want it over 1. So this would be 5 over 3. That is your scale factor, okay? What is the length of the pool? So we're going to solve for x here. We're going to set up a proportion, so 30 over 50 equals, I'm going to put x on top over 100. Again, check to see your diagonal numbers are across from one another. So side over side equals length over length. When I do that, I get 3,000 equals 50x. Divide by 50, divide by 50. And I get 60, I believe. Yep. X equals 60 feet. So this would be 60 right here in length. Find the area of the strictly reserved for sunbathing. So to find that, you're finding like the area of a donut. So it's all this stuff, right? So you need to find the area of the big guy. Area is length times width on a rectangle, so 100 times 50. So that is 5,000. That's the area of the entire thing. But from that, I have to subtract off the area of the pool. The area of the pool is found by doing 30 times 60, which is 1,800. If I subtract those two things, I get 3,200 feet squared. Okay? Okay, you're going to have two things for homework. You're going to have the 6.3 Schoology assignment that will go with this, and then in your supplemental packet, I want for you to complete this guy, and then I want you to complete this and then put the answers into Schoology. Okay, so two things before you go on to 6.4.